April 2026. A luxury cruise ship departs from Ushuaia, Argentina, carrying over 150 passengers and crew into the remote waters of the South Atlantic. At first, it's a standard vacation, but 5 days in, a 70-year-old passenger develops a severe fever. By April 11th, he's dead. The ship docks and his wife disembarks to take his body home. Before she can even board a connecting flight, she collapses in an airport terminal and dies right there on the polished floor. Soon, more passengers on the ship start falling ill. Ports refuse to let the vessel dock. The World Health Organization steps in, runs the lab tests, and finally identifies the culprit, Hantavirus. The baseline statistics for this pathogen are terrifying. It carries a mortality rate of up to 50%. There is no FDA-approved vaccine, and if you catch it, doctors can only offer supportive care. There is no known medical cure. But this specific outbreak breaks the usual rules of virology. Lab tests confirm the passengers are infected with the Andes strain. This is the only variant of hantavirus known to jump directly from human to human, completely bypassing its usual animal hosts. So we have an incurable, highly lethal pathogen spreading from person to person on a trapped ship. The obvious question is, why aren't global health authorities immediately triggering a worldwide pandemic lockdown? To understand why authorities aren't panicking, we have to look at the virus's history. During the Korean War in the 1950s, over 3,000 soldiers suddenly came down with severe fevers and mysterious internal bleeding. Military hospital wards quickly filled with men suffering from rapid kidney failure. The symptoms were so bizarre, doctors suspected chemical weapons. It took almost 30 years for researchers to isolate the cause. They eventually traced the pathogen to infected rodents living along the Hantan River in South Korea, which is how the virus got its name. Decades later, in 1993, the virus struck again, this time in the American Southwest. Members of the Navajo Nation, young, entirely healthy people, were dying rapidly as their lungs suddenly filled with fluid. Local tribal elders provided scientists with the critical lead, pointing to a specific climate pattern. A massive El Niño weather event had brought unusually heavy rains to the desert, creating a bumper crop of local pine nuts. This sudden abundance of food caused the local deer mouse population to absolutely explode. Millions of these hungry, infected rodents were suddenly pushed into extreme close contact with human homes, searching for shelter. This reveals the true nature of hantavirus. It doesn't spread in random waves. It is a strict environmental chain reaction, dictated entirely by climate cycles and localized rodent overpopulation. Which brings us back to our trapped cruise ship. These luxury passengers certainly weren't sleeping in dirty barns or interacting with wild mice. So how did the virus get on board? Investigations revealed that before boarding, the victims joined a birdwatching excursion in Argentina. But that specific tour led directly through a rat-infested landfill. That specific geographic exposure infected them with the Andes strain. Out of the entire hantavirus family, this is the single rare variant that has developed the ability to pass from one person to another. As this network diagram illustrates, scientists have documented that this specific strain can occasionally turn infected humans into super spreaders, rapidly passing the virus to multiple people in their immediate vicinity. So while the virus strictly relies on an environmental trigger to start, a single unlucky exposure to this specific strain can ignite a dangerous, highly localized human-to-human chain reaction within tight quarters. Despite that chain reaction, we aren't looking at the next global pandemic. This comparison shows the first biological firewall, how it travels. Unlike COVID or the flu, hantavirus is not airborne. It requires prolonged, extreme close contact to spread. The second biological firewall is time. The transmission window is incredibly small. An infected person is typically contagious for a single day. Hantavirus functions as a silent, localized assassin. It has quietly infected populations for decades, even leaving documented traces in parts of India without ever causing a large-scale outbreak. Because the vectors are local, the prevention is too. You protect yourself by sealing gaps in your walls, managing your garbage so you don't attract rodents, and always wearing an N95 mask when sweeping out old, dusty sheds or storage rooms. With no medical cure available, defense relies on proactive measures, hyper-local hygiene,